You know that feeling when you're talking to an AI? It feels a little bit like magic, right? You ask something, and this thing on the other side of the screen just understands and answers. But what if I told you that for most of AI's history, that magic was really just an illusion? What if the machine didn't actually remember anything at all?
Yeah, that's the wild truth. For decades, these machines had no database, no real understanding of the world, and zero memory of what you said even a sentence ago. It was all just a series of really clever tricks. So let's dive into the story of how AI finally learned to remember.
All right, we're kicking our story off way back in 1966 with ELIZA, one of the first chatbots ever. People would sit down, type out their deepest problems, and ELIZA would talk back like a psychotherapist. And get this, it was so convincing that some people felt a genuine connection, and they'd even ask for privacy to be alone with the machine.
So on the one hand, you have people pouring their hearts out, feeling truly understood. But on the other hand, what was ELIZA actually doing? Well, its secret was shockingly simple. It was understanding a thing. It was just programmed to spot keywords like mother or sad, and then slot your own words into a pre-written template. You'd say, I am unhappy, and it would parrot back, why do you think you are unhappy? No insight, just a simple script.
Here's the best way to picture it. Imagine ELIZA has a stack of index cards. Each card has a rule on it. If your sentence triggered a rule, it would spit out the response from that card. That's it. There was no notebook, no long-term memory, not even a short-term one. If it wasn't on one of those cards, it didn't exist. So the 70s roll around and researchers are getting way more ambitious. They were tired of these clever party tricks. They wanted to build machines that could actually reason. This pushed them to create new programming languages like LISP, which stands for list processing. The whole goal was to build an AI brain from the ground up, using pure logic and symbols instead of tricks.
So instead of using something like a spreadsheet, they came up with this idea called a semantic network. You can think of it like a giant mind map. You'd have a concept, a node, like bird, and you'd connect it with a line or an edge to other concepts like can fly or is an animal. This was a huge deal. It was the first serious attempt to give AI a structured memory of how the world works. This whole idea really exploded in the 1980s with something called expert systems. The goal here was to basically download a human expert's brain into a computer. A really famous one, XCon, helped a company called DEC configure their complex computer systems, and it saved them millions of dollars. And its memory? It was just a massive collection of thousands and thousands of if-then rules. But here's where it all started to go wrong. The AI's entire memory was this giant, tangled pile of logic. And these systems were incredibly brittle. That means if you had just one rule that was missing, or if two rules contradicted each other, the whole system could just break. It became a total nightmare to maintain. The hype bubble burst, and this problem helped trigger what we now call the second AI winter.
This Jenga tower is the perfect analogy. Imagine trying to update the AI's knowledge. You have to carefully pull out an old rule and slide in a new one. But because all the rules were so interconnected, every single change you made risked bringing the entire tower crashing down. It just wasn't a sustainable way to build a memory.
Okay, so while AI is over here dealing with its collapsing Jenga towers, another technology was quietly taking over the entire business world, the relational database. You know, SQL. It became the backbone for everything, and this put AI at a crossroads. Either stay stuck in its fragile world of rules, or figure out how to connect to this new universe of data.
And that brings us to a moment that honestly changed everything. IBM's Deep Blue beating the world chess champion Garry Kasparov in 1997. Deep Blue's secret weapon wasn't just its raw processing power, it was its memory. It had a massive database loaded with about 700,000 games played by chess grandmasters. For the very first time, big data was the fuel for a world-class AI. So, what did this new kind of structured knowledge actually look like? Well, it wasn't some abstract web of symbols anymore. It looked a lot like a spreadsheet, clean, organized rows and columns of data. This meant the machine could instantly look up patterns, analyze openings, and draw on a huge history of past games. It was a total game changer.
The whole model for AI memory just flipped. The AI wasn't a genius who had everything memorized. Instead, it was more like a super fast librarian in a massive library, the SQL database. It didn't have to know the answer to everything, it just had to be incredibly good at looking things up.
And that brings us right up to our current era. When large language models came along, they created a completely new kind of problem. See, SQL databases are fantastic at finding exact words or numbers. But what happens when you need to find a meaning? an abstract idea. That's just not what SQL was built for.
Let me break it down. If you ask a normal database to find happy, it's going to look for that exact 5-letter word, H-A-P-P-Y. It has absolutely no clue that joyful, glad, or content are related ideas. LLMs needed a memory that could understand these relationships, which led to a brand new invention, the vector database.
So what on earth is a vector database? Well, it's a wild idea. It doesn't store words as text. It converts their meaning into a long list of numbers, a vector, which is basically a set of coordinates. And it uses these coordinates to place ideas on a giant multidimensional map. The key is, concepts with similar meanings get placed close to each other on the map.
The best way to visualize it is as a giant map of ideas. Every concept has its own location. So when you search for something, you're not asking for an exact address. You're asking to be taken to a neighborhood of meaning. The words happy and joyful might be spelled differently, but on this map, they end up as next-door neighbors.
So where does all this leave us today? Well, we've kind of stopped pretending there's one single perfect database for AI. The real cutting-edge stuff is a hybrid approach, combining the best of both worlds to build a much, much smarter AI brain.
So a modern AI's memory has a few key parts. You've still got your classic relational databases, and they handle the hard facts, the prices, the customer IDs, the dates, anything that needs to be perfectly accurate. Then you've got your vector databases, handling all the fuzzy stuff, context, conversational history, and meaning. And the secret sauce that connects them all is an architecture called RAG.
RAG stands for Retrieval Augmented Generation. Sounds complicated, but the idea is actually super simple. Step 1, you ask the AI a question. Step 2, before it even thinks about answering, it goes and retrieves relevant info from both its fact database and its meaning database. And finally, step 3, it uses all that context it just found to generate a much more accurate and grounded answer.
I love this analogy of an AI with two bookshelves. One shelf is just for facts, encyclopedias, technical manuals, you name it. The other shelf is for meaning, stories, conversations, and context. Now, when you ask a question, the AI pulls from both shelves before it says anything. This is huge because this is how we're fighting AI hallucinations, by finally giving the models a library they can check before they speak.
So when you step back, look how far we've come. We started with canned responses in the 60s, we moved to brittle logic in the 80s, the 2000s connected us to big data with relational databases, the 2020s gave us the revolution of meaning with vector databases, and that brings us right to today, to these amazing hybrid RAG systems that combine it all. It all boils down to this: an AI is only as smart as its storage. The entire story of AI, every breakthrough and every setback, has been defined by how we've taught the machine to remember. From ELIZA's simple card tricks to today's hybrid brains, it's always been about the memory.
The goal has really always been the same, to build a machine that can remember and then use that memory wisely. So I'm curious, what do you think? When you look back at this whole journey, from fragile Jenga towers of rules to these new maps of meaning, what part of this story do you find the most fascinating? Thanks for digging into this with me.